HCI Lesson 16: The Principles of Universal Design. Defining universal design: the design of products and environments to be usable by all people to the greatest extent possible without adaptation or specialized design. The term universal design, or UD, has been mistakenly adopted by some designers as a synonym for compliance with the Americans with Disabilities Act or California Building Code. As we hope to demonstrate below, UD aspires for a place beyond compliance centered on meaningful inclusion of people with functional limitations without individualized accommodations. The original principles of universal design were developed by the Center for Universal Design at North Carolina State University under the leadership of Ron Mays, and originally published in 1997. Although the center is no longer in operation, the articulation of these guidelines sparked an international movement that includes a diverse body of scholarship, policy, law, and international agreements aimed to integrate people with functional limitations into the global social fabric. So here's the universal principles of universal design. So we have equitable use, flexibility in use, simple and intuitive use, perceptible information, tolerance for errors, low physical effort, and size and space for approach and use. And we'll be discussing this more in detail in the next slides. So equitable use. The design is useful and marketable to people with diverse abilities. So that is what we mean by equitable use. Equitable use is the first principle because it is the driver for accessibility. The principle promotes you to think about users with different abilities. When you use this principle, you must consider all users instead of only the target users. When you design for all users, you will also improve the experience for your target users and increase the brand value for your company. So these are the guidelines to achieve the equitable use. Number one is to provide the same means of use for all users. So it should be identical whenever possible, or if not identical, it should be equivalent. So number two is avoid segregating or stigmatizing any users. Number three is make provisions for privacy, security, and safety equally available to all users. So make the design appealing to all users also. So here are some guidelines and examples. So power doors with sensors at entrances that are convenient for all users. So as we can see here in this picture. So maybe we have here a grocery with sliding doors that maybe have sensors, so that even those with lesser mobility, or maybe the woman in a wheelchair, can be able to enter the grocery. And another example is integrated, dispersed, and adaptable seating in assembly areas such as sports arenas and theaters. So again, everybody can sit, etc. And how about for designing maybe a web page or any design? So in designing, use strong color contrast to avoid stigmatizing users with color blindness. So color blindness affects approximately 1 in 12 men, or that's around 8%, and 1 in 200 women, or 0.5% in the world. You can avoid segregating or stigmatizing your users by designing color palettes with strong contrast. One of the common myths about accessibility is if you design for accessibility, then you would be sacrificing the visual design. This is incorrect. A design with a strong color contrast can be aesthetically appealing to all users. Then let's proceed to number two, flexibility in use. When you say flexibility in use, the design accommodates a wide range of individual preferences and abilities. So we could say that no one person is the same as another. A static and inflexible design will never be able to accommodate all users. The flexibility in use principle encourages flexible, adaptable, and or customizable design. It takes into account individual preferences and lets the user choose how they will use a product. When you provide choices for your users, they will feel more free and more in control of their experience on your website. Guidelines. So provide choice in methods of use. So let's say, for example, in Microsoft Windows, we can choose the color, the theme of the user interface. We can also change colors. Accommodate right or left-handed access in use. Facilitate the user's accuracy and precision. Provide adaptability to the user's pace. So that means whether you're slow or fast, you can still be using the product or maybe the system or whatever. So examples, scissors designed for right or left-handed users as seen in the picture. So a left-handed or a right-handed person can use the scissors. An ATM that has visual, tactile, so that means you can feel it with your touch, and audible feedback. So the three should be there. Or a tapered card opening and a palm rest. So these are examples of flexibility in use. How about in designing? So maybe we can provide customizations for dashboards. Customization is a technique to accommodate a wide range of individual preferences and abilities. It enables users to choose and organize what they see on a website and how they will use it. Dashboards are good examples for customization. Many enterprise systems and project management applications have customizable dashboards. Depending on their various work tasks and needs, users can select what they want to see on the dashboard and how they want to use it. So here is an example. So this is actually a web-based project management application which is called Trello. So Trello is a web-based project management application. It uses boards, lists, and cards. So we have cards and we have lists. And this is the whole board. Maybe this is board. Or this is a card actually, footer card. So a card to help users to organize and prioritize their projects with flexibility. It offers a range of customizable dashboards options. Here, the user can choose the color of the cards to display on a board. So here we have here colors. So that means we can customize the colors. So that means it is flexible. So let's proceed to the number 3. Simple and intuitive use. Use of the design is easy to understand regardless of the user's experience, knowledge, language skills, or current concentration level. So that is what we mean by it should be simple and intuitive to use. Intuitive use. Simple and intuitive use is one of the goals of user experience design. It's not surprising this is also one of the universal design principles. This principle aims to reduce complexity and mental or cognitive loads. According to the cognitive load theory, humans can handle only 3 to 9 items in a short amount of time when processing information. So as to reduce complexity and reduce cognitive loads, you should always aim to present information between 3 and 9 items. So guidelines. Eliminate unnecessary complexity. So if there are unnecessary options, for example, you can reduce them. So just like applying Hicks law. Be consistent with the user's expectation and intuition. Accommodate a wide range of literacy, and language skills. So don't use highfalutin words, don't use jargons. Arrange information consistent with its importance. So maybe the more important things should be placed on the first position. Provide effective prompting and feedback during and after task completion. So we already have studied about feedbacks. So example, a moving sidewalk or escalator in a public space, or an instruction manual with drawings and no texts. So that would make it more simple rather than just pure text. So here you can, I don't really understand this much because it's quite blurred, but I see here somebody waving or maybe some sort of a sign to this one. And of course, it should be a simple sign so that this can understand what is this about. And that is what we mean by simple and intuitive use. So how about in design? So we reduce visual clutter with progressive disclosure. Progressive disclosure is an interaction design technique. It reduces visual clutter and removes irrelevant information on the screen. So that's one of the principles. Remove irrelevant information on the screen. It prioritizes information to display on the screen based on user needs and interactions. On top of that, it allows the user to drill in for more information, usually without a page load. Progressive disclosure reduces users' cognitive loads and helps them focus on the task at hand. So here's an example. The MailChimp is a web-based email marketing service. On its pricing page, it uses progressive disclosure to display service plans. A user can interact with a slider, so we have here a slider, to communicate the number of subscribers to whom she will be reaching out using MailChimp. Based on the input, MailChimp displays a subset of 3 service plans on the screen, so we have 3 screens, and recommends one of them to the user. And of course, if you click on one, then it will be showing only something about this. So that will make it simple rather than displaying all of these at the same time. Perceptible information. The design communicates necessary information effectively to the user, regardless of the ambient conditions for the user's sensory abilities. Information is critical to users, whether it's communicated via text, pictures, audio, or videos. Make sure the information is easy to digest and access. When you incorporate this principle into your design, start with your users. You can figure out how best to present information by considering users with disabilities, such as those with vision or hearing impairments. Guidelines. So use different modes. So you can use pictures, verbal, or tactile for redundant presentation of essential information. So maybe the users can view information in several ways. We have seen this. Sometimes we have text, and again we have also videos. So that's example of using different modes. Maximize legibility of essential information. So it should be clear, it should be readable, the essential information. Differentiate elements in ways that can be described. Make it easy to give instructions or directions. Provide compatibility with a variety of techniques or devices used by the people with sensory limitations. So we have already discussed about those with limitations. So examples: tactile, visual, and audible cues and instructions on a thermostat. But here in this picture, we have here the old style cell phone, old school cell phone, where actually we can easily determine if we have pressed a key, because it's some sort of give us a tactile feedback. So redundant queuing. So examples, voice communications and signages in airports, train stations, and subway cars. So maybe if you have tried going to an airport, which I haven't, there will be some announcements. So let's say, for example, that your flight 101 will be blah 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 blah. So all passengers, so these are queuing, or maybe they are signages. This way to this one, etc. So these are examples of perceptible information. How about in design? So in design, we enable users with hearing impairment to watch videos with video transcription. So multimedia requires multi-sensory experiences, especially videos. People with hearing problems or language barriers have difficulty consuming information from videos. You can remove these barriers by providing video transcription and or subtitles. Video transcription and subtitles add an alternative channel. They allow users to consume words and information from the video without relying on hearing. Designing with accessibility in mind can be a win-win situation for both the company and the users, just as it is for TED. So here is an example, TED Houston. So we have here subtitles and transcript, etc. So these are actually the transcripts. So once we view the video, this will be displayed or some sort of a caption, subtitles. Maybe you're familiar with that, subtitles. So TED is a non-profit organization which is dedicated to spreading ideas via short power talks. The talks are usually 18 minutes or less and are often uploaded as videos on their websites. But in order to reach and help as many users as possible, TED's website provides subtitles and transcriptions of their online videos. It also provides the option to select a language. That's a huge service for the hearing impaired user. And it's a great service for everybody else who prefers to read instead of viewing and hearing videos. So maybe just like what you do with K-dramas. In turn, it's also good for TED as they reach more users and increase their popularity. When designing for accessibility, this is most often the case. It's a win-win situation for both the users and the companies or organizations we design for. So let's go for number 5, tolerance for error. When you say tolerance for error, the design minimizes hazards and adverse consequences of accidental or unintended actions. According to Hans-Peter Dörr, a German physicist, human beings should only use technology which, if the worst case happens, it leads to an unacceptable damage. Definitely, nuclear energy is not in that category. So, and that's the reason why there is still a less use for nuclear energy. I want an industrial world where people are allowed to make errors, because human creativity has to do with being allowed to make errors. We want an error-friendly environment. Errors are inevitable amongst humans, hence the adage, to err is human. While we are not designing for nuclear technology, we should design for an error-friendly environment. Universal design aims to design for all users, as well as design in anticipation for different environments and users' actions. This principle pushes you to think beyond the screen and how the system and user will interact with each other. So the guidelines for tolerance of error. Number 1 is arrange elements to minimize hazards and errors. Most used elements should be most accessible, and hazardous elements eliminate, isolated, or shielded. So let's say, for example, we have buttons like add, edit, delete. Then most probably the delete should be the last button, not the first one. Provide warnings or of hazards and errors. Let's say, for example, do you want to delete this record? Do you want to format this disk? So these are examples of tolerance for errors. Provide fail-safe features. Let's say, for example, we can undo. Discourage unconscious actions in tasks that require vigilance. Examples: a double cut car key easily inserted into a recessed keyhole in either of two ways. So we have double cut car key. An undo feature in computer software that allows the user to correct mistakes without penalty. And here in this picture we can see that I think this is a drill machine, and we have here this one, so that will make it maybe safer and lesser prone to error. How about in design? So in design, we can reduce submission error with form validation. Form validation minimizes and prevents user errors. There are 3 ways to validate form inputs. Number 1 is input form validation. Make sure that the user has used the correct format for an input field. For example, the email address input field should have a format started with a string of alphabets or letters followed by @ and an email domain name. Then next is data validation. Check to make sure whether the data the user entered is in the correct context. For example, many hotel reservation systems need check-in dates to be no earlier than the current date. So if you place a date that is earlier than the current date, that means there's something wrong. That's data validation. Server validation, input format validation, and data validation are applied to a specific input field. Server validation sends all the data of a form to the server and checks for a correct data relationship. For example, a simple login form would use server validation to check whether the username and password are correct. So here's an example. So this is actually from Twitter. Twitter is an online social networking service which allows users to send and read messages of 280 characters or less. Here is Twitter's sign-up form with error messages for input format validation errors. So that's why we have red here, but they are too small. But it checks for correct email and password format. So it says here maybe that the email is invalid or the password is also invalid. The next is low physical effort. So how do we achieve this? So when we say low physical effort, the design can be used efficiently and comfortably and with a minimum of fatigue. We may not first associate physical efforts with using a web for any design. Anyone can easily just sit down and use a mouse, but technology is now integrated and ubiquitous in workplaces. That means it is everywhere. Many people are using their computers for 8 or more hours to perform tasks at work. The amount of time we spend on our computers is taxing on our bodies. In fact, people with physical disability have even more difficulty with using the web than normal users do. For example, those with mobility issues may have a hard time moving the mouse to the desired target. This is why designing for low physical efforts is vital to bear in mind whenever we work. So guidelines allow user to maintain a neutral body position. Use reasonable operating forces. Minimize repetitive actions and minimize sustained physical effort. Example, a lever or loop handle on door and faucets. So here's an example. So using this rather than the rounded doorknob, this will require lesser physical effort. Or touch lamps operated without a switch. So instead of reaching for the switch, we can just touch the lamp. So we already have a lot of this. How about in design? also minimalize mouse usage with keyboard shortcuts. So that is for low physical effort. Keyboard shortcuts reduce the need to move from the keyboard to the mouse for simple tasks. Most browsers such as Chrome, Firefox, and Safari provide keyboard shortcuts to perform tasks such as copy, that is pressing Ctrl-C, and paste, Ctrl-V. You can design superb interactive experiences by adding appropriate keyboard shortcuts. They will improve the navigation and make websites easier to use for all users. So here's an example. Asana is a web-based project management platform. It allows teams to track and manage work items. And Asana has a rich set of keyboard shortcuts. So these are the shortcuts actually. So shown here, we have, I cannot see, but tab something. These shortcuts reduce mouse usage and minimize repetitive actions. So we have a lot of applications that makes use of keyboard shortcuts. And number 7, the last one, size and space for approach and use. Appropriate size and space is provided for approach, reach manipulation, and use regardless of user body size, posture, or mobility. For product designers, their focus is on form factors such as the size of and space involved with the product. As digital designers, our focus is less on form factors but more on what is on the screen. This is a short-sighted mindset because it is important to think outside of the screen and consider our users' environment as well, especially as users view websites not only on desktops but also increasingly on mobile devices as well. Actually, that's rather the trend now. So we view more on mobile devices rather than desktops. As you can see, most of the guidelines for this principle apply more to product and environmental design. Nevertheless, we can still look at the principle of its guidelines so as to create a universal design website, one for both desktop and mobile devices. So that's why, for example, in our web design class here at the University of Luzon, so we are actually teaching you some ways to make your web design website responsive, so it can be viewed on desktop and mobile devices. So guidelines provide a clear line of sight to important elements for any seated or standing user. Make reach of all components comfortable for any seated or standing user. Accommodate variations in hand and grip size. Provide adequate space for the use of assistive devices or personal assistants. So these are all self-explanatory. Example: controls on the front and clear floor space around appliances, mailbox, dumpster, and other elements. So they should be in the front. Wide gates at subway stations that accommodate all users, just like in this example. Then there should be a way for those with having wheelchair to enter. So what if, for example, the space is not enough? So here they provided space that will be enough for those using wheelchairs. That's an example of this. How about in design? Consider the target area of your website when it is on mobile device. On a desktop, a user interacts with the website via a small pointer on the screen. On a mobile device, a user interacts with the website using his or her index finger or thumb. A small target area can be a problem on mobile devices because it is more difficult to select with precision. Actually, I'm having this problem, so it's hard for me to type text using my cell phone as compared with using a laptop or a desktop. So according to an MIT Touch Lab study in 2003, the average size of a human adult finger is around 1.6 to 2 centimeters. Converting that, we have approximately 60 to 76 pixels on a digital screen. So the next time you design for mobile Make sure your touch target areas take the human physical factors into consideration. That means your button should be around this size, minimum. It should be at least this size or maybe even larger. So here's an example. Yeah, actually this was the example a while ago. So according to MIT Touch Lab study in 2003, the average size of a human adult index finger is 1.62 centimeters. If you convert that to pixels, then it's approximately 60 to 76 on the digital screen. So you can improve the accessibility of your product if you provide adequate target areas for your users. So you have to consider the size of your finger. Now, the importance of universal design. The most important international work on accessibility is the Convention on the Rights of Persons with Disability, or CPRD, or CRPD. We refer to it as a convention by lawmakers and the disability community. It is the first major human rights treaty on the 21st century, and it protects the right and dignity of persons with disabilities. It calls for the removal of environmental and attitudinal barriers in physical and digital spaces. The United Nations adopted the CRPD in 2007. As of July 2015, as many as 157 countries had ratified the convention and 159 countries had signed it. The convention listed universal design as one of the general obligations to protect the rights of persons with disabilities. To undertake or promote research and development of universally designed goods, services, and equipment and facilities as defined in the Article 2 of the present convention, which should require the minimum possible adaptation and the least cost to meet the specific needs of a person with disabilities, to promote their availability and use, and to promote universal design in the development of standards and guidelines. The takeaway or the conclusion. Creating accessible products can be a challenging task. Sometimes we as designers do not know where to start. Universal design is a solid approach to design because the 7 principles help us consider the needs for all users in general. Universal design benefits everyone, not just the aging population or people with disability. The principles of universal design is a great resource for us to use when we want to design accessible websites, ones which serve and cater to as many users as possible. These principles will help guide your design process. Thus, you should incorporate them into any project you do from the very beginning. So that ends my video lecture, and thank you very much for viewing this video. See you again on my next lecture.